Boleh nampak skrin saya ke? Boleh nampak? Okay, good. Kejap saya try record. Lepas kita start ya. Kejap. Tak nak. Terus 10 dah. Okay. Bismillahirrahmanirrahim. So, baru 10 orang. Tak apalah. Walaupun 10 kita start je lah sebab just to respect the others yang dah join kan. Okay. Okay, so Assalamualaikum warahmatullahi wabarakatuh and a very good evening to all of you. Okay, so let's start our class today with the doa. So maybe for today, Muhammad Nazmi, can you recite a doa? For non-Muslim, you can recite by yourself, okay?
Yeah. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi.
Amin.
Allahumma sabata wa syai'na sabata wa syai'na qadra innaka ta'afu wa rasul. Wa bihi wa fi asma'i wa tamthila tawban. Rabbana ya Allah wa fi akhirati hasanatan subhanaka Alhamdulillahirabbil alamin.
Amin. Okay, thank you so much, Nazmi. Okay, so for today, we are in week 12. But in the calendar academic, we are in week 13 actually. Okay, so we will learn about chapter 4. Okay, so chapter 4. Okay, so chapter 4 is about the mass transport. Okay, so mass transport, basically for this week, we will have 2-hour lecture, and then we will not have the tutorial. Okay, 2-hour lecture only. So for this week, we'll cover subtopic 4.1, which is about the molecular mass transport, which involves the fixed law of binary diffusion. And then we go to 4.2 to estimate the mass diffusivity. And the last subtopic, we learn about the mass and molar by convection. Okay, so you can refer on the textbook on page 513 to 524, and also at page 533 to 537. Okay, this is the overall view of this chapter 4. So basically for chapter 4, we divide into 3 sections. This is first section, second and third, and we'll cover for 3 weeks normally. So this is week 12, week 13, and week 14. Okay, but in your case, we'll cover, this is week 13, 14, and this will cover in the study week. Okay, so we start our chapter 4 with the fundamental. Okay, first we will learn about the fundamental, which is the diffusivity and the mechanism of mass transport. So fundamental, we look at the two types of the transport of the mass, first by molecular and second by the convective. Okay, and then we will estimate the mass diffusivity. Okay, after that, after we have learned the fundamental, then we will develop the mass concentration profile by using shell mass balance method. Okay, we will look at two systems. The first system is the diffusion through a stagnant gas flow, and then second system is diffusion with the heterogeneous chemical reaction. Okay, and the last part is the after we have developed the mass balance by using shell method, then we can compare by using another method, which is we use the equations of change. Okay. So for equations of change here, we use the equations of continuity for multi-component mixture. Okay, it's quite similar with the momentum and energy transport step here. Okay, first we look at the fundamental, then we go to the shell balance, and then we go to the equations. Okay, similar. Before we go further, there is a few terms that we need to know before we can proceed with the mass transport. Okay, the first term is the mass concentration. So mass concentration basically is the density. So density is equal to mass over volume. Okay, so for pure component, for example, component A, so mass concentrations of component A is mass of A, we divide with the volume of the system. Therefore, we got density A. So we can read as mass concentrations of A. So this is equal to the rho. Rho here means that the overall system. So because our system is pure component, therefore rho A is equal to rho overall system. Okay. Meanwhile, for the binary component, binary here means that we have two components. For example, component A and B. Therefore, the mass concentration is the mass of A plus mass of B. We divide with the volume of the mixture solution. So you get density. Okay. And then this density basically ataupun total mass concentration is equal to mass concentration component A and B. Okay. Okay, and then the second term that we need to know is the mass fraction. So mass fractions omega A. So omega A is equal to mass concentrations of component A, you divide with the total mass concentration. So for example, for binary system A and B, so density A you divide with the density A plus density B, which is the total. So we can change density A is mass A over volume of solution, similar to the density B and density A. So finally here we can simplify the volume, we can cancel out. So we get mass A over mass A plus B. So mass A plus B basically is the total mass in the system. So we can set that mass fractions of component A is equal to mass A divided with the total mass in the system. Okay, so basically the mass concentration and mass fraction you have learned before. I just refresh back. Okay. Okay, this is the notation for the mass. Meanwhile, this one is the notation concentration in terms of molar. Okay, what is the molar? So basically here the molar. So molar is equal, molar concentrations is equal to density. Mass concentration, you divide with the molecular weight. Okay, that is differences. Okay, and it used for the mass omega A. So for the molar concentration is XA. Okay. Okay. So in this chapter, we start by giving fixed law of diffusion, which describes the movement of one chemical species A through a binary mixture of A and B because of concentration gradients of A. So in introduction in chapter 1, we know that the mass will be transferred if there is a concentration gradient. Means that from the high concentration to the low concentration region. Okay. 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 So for example here, there is in a beaker, so there is water. So in this water, there is a small crystal of the potassium permanganate. Okay. So at this point, the concentration is very high. Meanwhile, at the surrounding, the concentration is very low. Concentrations of what? Concentrations of the potassium permanganate. Okay, so because of the different concentration, from the mass of the potassium permanganate will diffuse from the high concentration to the low concentration. So finally, we get that all the beaker here, the color will be similar, and at any point in the beaker, it will have the similar concentration. Therefore, the mass transfer will be stopped. Okay. Okay, now we look at how the fixed law of binary diffusion was developed. So this fixed law of binary diffusion is also known as the molecular mass transport. So consider a thin horizontal fused silica plate of area A and thickness Y. Suppose that initially for time t less than 0, both horizontal surface of the plate are in contact with air, which we regard as completely insoluble in silica. Okay, so this is the figure. So basically, this is the fused silica. So this fused silica is a B, component B. Okay, at the upper is air, at the bottom also air. So the thickness of the silica is Y. Okay. Then air at the bottom here was replaced suddenly by using helium. And we know that A will not dissolve, cannot dissolve into which is insoluble to the silica. But helium can dissolve into the silica. Therefore, the concentrations of helium here is omega A naught. So A is the helium. So our system is a binary system. Okay. So at the upper, the mass concentration of helium is 0. So because of different concentration, so the helium will diffuse to the upward. Okay, so it diffuse into the upward. Therefore, you think kat sini, the mass concentrations of helium is changed with thickness and time. Okay, so as time go by, it achieves a steady state condition. So at steady state condition, the concentration become linear. Okay, so kalau lihat kat sini, the axis is X, at the here is Y. Therefore, the helium is transferred to the positive Y direction. Okay, what about Y? Okay. Okay, so this is the descriptions of the figure. Okay, maybe I repeat again. So at time t is 0, the A below the plate is suddenly replaced by pure helium, which is applicable soluble in silica. So the helium slowly penetrates into the plate by virtue of its molecular motion and ultimately appear in the gas above. Okay, tadi ada cakap, so dia akan naik ke atas lah. This is helium. This is air. So the molecular transfer of one substance relative to another is known as diffusion. So the A above the plate is being replaced rapidly so that there is no applicable build-up of the helium there. So at the above ataupun upper plate here, there is air. So normally the A, there is velocity here of the A to remove the helium that is built up, the concentration. Because of what? Kalau tak ada velocity here, the concentration of the helium akan increase. So bila increase nanti dia akan diffuse to the downward. So bila ada velocity of the air, so dia akan swept away the helium. So it maintain the concentration of helium here low compared to the below. So diffusion still akan ke atas lah. Okay. Okay, so the mass fractions omega A is the mass of helium divided by the mass of helium plus silica. So we know lah VA is equal to mass helium. We divide with the mass helium plus mass silica. Okay, ataupun total mass. Okay, so that at steady state kat mana kelas? At here. Okay, so at steady state, it is found that the mass flow omega AY of the helium in positive Y direction can be described to a very good approximation by, so omega AY divided with the area, A is the area, is equal to density mass diffusivity DAB times with the differences of WA naught minus 0 over Y. Y is the thickness. So this term is a concentration gradient. Meanwhile, omega A divided with the A basically is the mass flux. Okay, so this we look as the macroscopic system. Okay, so in a microscopic system, omega A Y over A we can transfer as a mass flux. So GAY equal to negative rho DAB. So the concentration gradient is d omega A over dy. Y is negative because of the slope of the graph here is a negative. Okay. Okay, so this is one-dimensional form of Fick law. Okay, so that how to read this one, the mass flux. So mass flux here, dekat sini. So it show that A here is the atom ataupun compound ataupun substance. You can say as a atom pun boleh. So A, for example, I say A is the component A diffuse in the positive Y direction. So kalau cakap GAX means that component A diffuse in the positive X direction. So if I say GAZ means that component A diffuse in the positive of Z direction. Okay. So it is valid for any binary solid, liquid or gas solution provided the GAY is defined as the mass flux relative to the mixture velocity Vy. Okay, so that kalau tadi I cakap this is one-dimensional form of Fick's law. So that kita boleh jawab for Cartesian coordinate, kita ada this is in the X direction, this one in the Y direction, and this is in the Z direction. So in general, we can write as a, for the three dimension, you can say that GA, so J is bold, right? So equal to negative rho DAB divergent omega A. So bila tengok bold here, means that kita akan ada three direction. Either kita ada GAX, GAY, or GAZ. So which direction? So omega similar. Either kita akan ada DWA, d omega A per dx per dy or per dz. Okay. So this one you need to remember. You mesti ingat. So kalau I cakap molecular transport equation, this is, which is it obey to the Fick's law. Okay. So as conclusion, if we can compare our transport phenomena, which is the momentum, heat, and mass transfer, the differences of these three transport phenomena. So in terms of driving force, tengok momentum transfer is the velocity gradient, heat is temperature, meanwhile for the mass is the concentration. For transport property, for momentum is viscosity, heat, the thermal conductivity, meanwhile for the mass transfer, the transport property is mass diffusivity. So law that relate to the process is the Newton's law of viscosity for the momentum, Fourier law is the heat transfer, Fick's law of the mass transfer. And also you need to remember the equation. For example, Newton's law, tau is equal to negative mu dvx over dy, for example. So kat sini kita ada yx. And Fourier law, qy is equal to negative k dt over dy. Meanwhile, for the fixed law, for example, we have j a y is equal to negative rho dab d omega a per dy. Okay, so we need to remember. So kalau from my analysis, this table is a very popular question in the FA. Normally, kalau I lihat, kalau I analysis, I found that for the question number 1, it is frequently asked the differences between these three transfer phenomena. Okay, so make sure you know what is the differences and what is the similarity. Okay. Okay. Then for the mass diffusivity, DAB, there is a relationship with the temperature and pressure. Okay, for the gas system, if the temperature increase, the DAB will also increase. However, if the pressure increase, the DAB will decrease. Okay, for the liquid system, when we increase the temperature, the DAB also will be increased. So we found that the mass diffusivity, the thermal diffusivity, means this is for heat, this is for the momentum, this is for the mass, and the momentum diffusivity, which is known also as kinetic viscosity V, all have dimensions of length square over time. So that DAB, then alpha, and also the V. So the similarity, it have a similar unit per time. And the ratio of the three quantities, we will have the Pratt number, and then Smith number, and also Lewis number. So what is the applications of this number? So for the Pratt number, it is normally applicable for the heat and momentum transfer. Smith number for the mass and momentum transfer. Meanwhile, for the Lewis number, involve the heat and mass transfer application. So in the textbook, if you refer table 17.1-1, 2, 3, and 4, some value of DAB, mass diffusivity, in centimeters square per second are given. Okay, for fuel, gas, liquid, solid, and polymer system. This value means that it got from the experimental. Okay, so that if we don't have the value, we can use another method, which is estimation. Kita akan estimate lah the value of the mass diffusivity. Okay, so now we have learned about the Fick's law. This is the Fick's law. So beside the Fick's law, there is another expression of the mass flux for the binary mixture, which is known as the GAY is equal to rho A in bracket differences between the average velocity of A in the y direction minus mass average velocity of the mixture. Okay, why is y? Because just too similar for this one lah. This one in y direction, so this also in y direction, in a positive y direction. Okay, so how it come up with this one? So basically here we consider a system which consists of atom A. So atom A is the small circle with the blue color. Meanwhile, atom B is a bigger circle with the green color. Therefore, the atoms were randomly with variety of magnitude within range and direction here. Okay, so there is VA here kan. So VA means refer to atom A. So here VA means that the values, this is the average. So there are the velocity in the X, in the Y, and also in the Z direction. Okay. Okay, so kita consider velocity in the y direction. So kita akan consider in the y direction for both A and B. And we found that the velocity of atom A is greater or bigger or faster than atom B. So that is the visual. In terms of visual, kita akan lihat sini, velocity of atom A is greater than average velocity of atom B. Okay. Okay. Therefore, the mass average velocity of the mixture in y direction is known as Vy. Okay. So this Vy basically is the value must be greater than Vby and less than Vey, because Vy is the mass average velocity of the mixture in the y direction. And this Vy is influenced or depend on the concentrations of A and B and also the individual velocity of A and B. Therefore, this Vy is equal to omega A times with the average velocity of A in y direction plus mass concentrations of B times with the average velocity of atom B in y direction. So you need to remember this one. Okay. So relative velocity of Vay against the average velocity of the mixture. So this one lah. So the unit is meter per second. So if I've times with the mass concentrations of A, component A, the unit become kilogram of A divided with the meter square per second. So this is the mass flux. That's why the GEY, the mass flux of component A in a positive y direction, is equal to density A, the relative velocity between the VEY minus V. Okay, so if your system binary system, you boleh buatlah. So GEY. So for the B, JBY is equal to rho B in bracket VBY minus VY. So it is applied also for multi-component system. For example, beside A and B, you have other component which is C and D. So that you can write that for the mass flux of component C in the positive y directions is equal to rho C VCY minus VY. And well, for the mass flux for the component D in y direction is equal to rho D V dy minus Vy. Okay, so this is in y direction. Kalau let's say in the x direction, so whether G is equal to rho C V Cx minus Vx. So similar G dx rho T V dx minus Vx. Kalau Z, tukar je lah. Okay. Okay. Then we know also from this mass transport, it also found that sum of mass flux is equal to 0. Okay, sum of mass flux is equal to 0. So kita consider binary system, component A and B in y direction. So kita ada dua component kan. So mass flux of component A. So we can write like this one. Mass flux for component B. This one. Okay, so when we sum of the mass flux A and B, so bila kita pluskan dia, So kita boleh tulis balik lah. Okay, and then kita boleh kembangkan dia. So it become this one. So we know that tadi kita dah belajar what is the mass fractions. So mass fractions of component A is equal to the density divided with the total density. Mass fractions of component B, density B divided with the total. So that you can rearrange, you boleh replace for the density here. You boleh replace. Okay, so bila you replace here, kat sini je you tak tulis ni. So you replace here, you boleh rewrite atau simplify become this one. And we know that total density is density A plus density B. Okay, so here you can replace as the total density. Okay, okay. Meanwhile for the here, ingat tak tadi kita dah belajar? Ada kata you kena ingat, which is this one. The mass average velocity of the mixture is equal to mass fractions times the average velocity of component A plus mass fractions of component B times with the average velocity of component B. Okay, so that we can replace here with the Vy. So finally, is equal. So this one minus this one becomes 0. So it is proven lah. Okay. So that sum of mass flux is equal to 0. Okay, what is this? Okay, this one I dah discuss tadi kan? Ya ke? Discuss. So kita tahu kalau mass average velocity here tadi, mass average omega times with the individual average velocity individual. If molar, kalau molar, beside dia ada star kat sini. Beside by using omega here, you akan using x2 apa? Ni mass fraction, this molar fraction. Okay. Okay, and then V alpha minus V ni maksudnya diffusion velocity of species alpha with respect to the mass average velocity. Kalau V star here means that diffusion velocity of species alpha with respect to the molar average velocity. Okay, okay, okay. Now we would like to prove the mass diffusivity, for example, in binary system. DAB is equal to mass diffusivity of BA. The value is similar. Oh, but before that, okay, what is the meaning kalau dikatakan mass flux is equal to 0? Apa maksud dekat situ? It is mean that kalau kat sini kenapa 0 ni menunjukkan bahawasanya the magnitude of mass flux of JA Y is similar to the mass flux of BY, but the differences different in the direction. Direction dia saja berbeza. For example, JAY the magnitude is 3, but for the JBY the magnitude also 3, but different direction. That's why it become 0. Okay, so 3 and negative 3. What does it mean? Magnitude dia sama, tapi dia punya direction berbeza. Tidak sama. Okay, itu maksud dia. Okay, we go back. So this one just to prove that mass diffusivity of DAB is equal to mass diffusivity of BA. Okay, tadi kita tahu sum of mass flux is equal to 0. Now we use the fixed law. For example, JA plus JB is equal to 0. So kita must substitute with by using the fixed law. So we substitute here is equal to 0. Then we know that mass fractions of A plus mass concentration A plus mass concentrations of B, mass fraction lah, betul lah, mass fraction is equal to 1. Okay, so boleh rearrange, kita boleh substitute here. And then simplify, become this one, and this is the constant value lah kan. Constant means that kita boleh cancel out. Sebab this one 0, so cancel out. So finally we got this one, and last one. Okay. So so that it is proven lah. Okay. Okay, so that's the 4.1 we have learned about the fundamental. So fundamental, dua benda which involve the molecular mass transport. You kena tahu. Yang pertama tadi apa? By using the fixed law. So for example, GA okay, is equal to negative rho DAB negative B divergent WA. Okay, second, another expression kita boleh guna JA is equal to rho AV. Right, dua benda ni kena ingat lah. Jangan tak ingat pula. Okay, now we want to estimate the DAB. Kenapa? DAB is a mass diffusivity. The apa tadi kita panggil? The transport property. Okay, so in this section we discuss the predictions of the diffusivity DAB for binary system by corresponding state method by using the figure lah. Okay, for binary gas mixture at low pressure, DAB is inversely proportional to the pressure increase with the increasing temperature and is almost independent of the compositions for a given gas pair. The following equations for estimating DAB at low pressure has been developed from a combinations of kinetic theory and corresponding state argument. So you can use this equation to estimate the DAB. Okay, instead you kena tahu the critical pressure, critical temperature, the molecular weight, baru dia boleh cari. Okay, similar with the momentum. Kalau dulu kita belajar momentum, kita nak cari apa? Kita boleh estimate apa? The viscosity. Kalau heat transfer, kita nak estimate thermal conductivity. Okay. Okay, by using corresponding state method, we can use this one. Okay, similar, ingat tak? So kita ada reduced temperature, and then the curve here is reduced pressure, and then for the Y here adalah reduced self-diffusivity. So self-diffusivity ni kita ada CDA, kita ada ni. Star, this is for reduce pun sama, either in the molar ataupun in the mass. R, reduce. Okay, so you can carilah TR. So how to find TR? TR, temperature divided with the critical temperature. Pressure, ni dah berjuta kali dah saya cakap. Dah pernah bagi lecture lah. So pressure di PR, pressure divided with the P critical. So how to get the TC and PC? From the appendix. Okay, so kalau kat sini pula. Okay, so CDAA self-diffusivity for the R is equal to mesti ada this value lah, over critical. Okay, ataupun kalau I boleh buat general, A is equal to A reduce is equal to A over A critical. So A ni can be anything, temperature, pressure, self-diffusivity. Yang sini you jangan confuse pula kelas. Kat sini, apa beza C dengan density? It's similar lah. Kalau density ni maksud dalam unit mass, dia nak guna mass lah. Kalau C ni mesti nak guna molar. Okay. Apa AA pula? AA means that your system is a single system lah. Komponen A sahaja. Okay. So then the quantity so critical value may be estimated by one of the following of these three methods. Okay, the first one, given CDAA at non-temperature and pressure, one can reduce self-diffusivity from the chart and get the critical. Okay, maksudnya pressure, temperature given, so that you ada TR. T is given bagi pada T critical. PR, P is given. So dua value ni dan guna the chart. Guna chart ni tadi, mana? Okay, dua ni, for example 2 and sini 10. So dapat ni, you boleh cari dia punya self-diffusivity. This is dia reduce kan? So you dapat reduce punya value. Then you guna equation to find the critical lah, sebab this value is given. Okay, so you boleh estimate. The second one can predict a value of CDA in the low density region by method given in section 17.3 and then proceed as in one. So you can refer this subtopic 17.3 and then you can proceed with the number one. Okay. And then number 3, one can use the empirical formula. So see problem 17A-9. So empirical formula means that you guna je equation ni. So critical ni boleh dapat dengan cara you guna equation ni. You masukkan value molecular weight and then you masukkan the critical pressure and temperature. So you dapat. And then for the binary diffusion, kita boleh guna this equation. Maksud dia guna equation lah to estimate the CDEP. Okay. Okay. So in order to make sure you understand about how to estimate the mass diffusivity, you can look and try the example 17.2-1, 17.2-2 and 17.3-3 in the textbook. And this example is a guided solution. So that you boleh tengok lah, but dia dah guided, so I tak discuss lah, you boleh tengok one by one. But you are still free to ask me if you have any question. Okay, any question regarding to the subtopic 4.1 and 4.2? Ada sebarang soalan? Ada, so we proceed to 4.3. Okay. 4.3. Okay. Okay, so 4.3 kita akan masuk mass and molar convection. Okay, kita dah belajar kalau transport ni kita akan either dua, sama ada by molecular and by convective. Convective ni sebab apa? Because of the bulk flow. Okay, sebab adanya bulk flow, therefore kita ada convective, transport by convective. Okay, so kita tengok mass and molar. Apa beza mass and molar? Sama je, cuma dia guna molar and dia guna mass. Okay, okay, we consider a small element of the volume delta X, delta Y and delta Z with this velocity V. So this velocity kita tengok dia ada Vx, Vy and Vz. And then the mass being carried through the area of ds by flow, by bulk flow. So consider flow in the x direction. So kita can consider in the x direction. Therefore, this direction is perpendicular to this area lah. Okay. So that mass flow rate of A in x direction by flow is the density of component A times with the velocity in the x direction times with the area. Okay. So finally, you will get the unit is mass of A time over second. And this value, if we divide with the ds area, we divide with the area, so the unit become this one. Kalau kita divide with ds, so kita can cancel out, kita akan dapat this one lah. Okay, so rho E Vx. Okay, so this is in x direction. What about in the y direction? So kalau y, rho E Vy. What about in the z direction? So rho E Vz. So kita lihat in one dimension. Okay, so in general, kita boleh tulis for the 3 dimension, kita akan jadi rho E V. So this is known as the convective mass flux. Okay. So kat sini maksudnya apa kelas? Kita tengok ada V kat sini kan. So V ni ada 3 lah. Vx, Vy, or Vz. Okay, this for component A. Kalau component B, kita ada rho B, V. Rho C, kalau component C, rho C, V. Cuma V ni ada 3 lah. Vx, Vy and Vz. Depend on the direction. Okay. Okay, kita dah tahu molecular, kita dah tahu convective. Now another term is a combined mass flux. Sama, kalau dalam momentum pun kita dah apa? Combined momentum flux. Energy, combined energy flux. Ingat tak? Ingat kan? Cuba recall back. Kalau momentum, kita ada apa? Combined momentum, kita guna apa? Ingat tak? Tak ingat? Apa lagi? Tahu rho VV plus, apa lagi tak? Tak ingat ke? Ingat ke tak ingat? Akasha ingat tak? Mana Akasha? Mana aku punya nota tu? Plus dengan P delta, right? So this is by molecular and this is by convective. Ingat tak? Kan? So tahu dia akan guna Newton's law. So rho VV itu lagi P delta. This is of pressure and this is due to the viscous stress. Kalau heat, kita ada apa? Combined energy flux, right? Which is equal to apa? 1/2 rho V plus Q by convective plus by P. Ingat tak? You kena ingat lah, okay? And then combined mass flux, the last one untuk mass, combined mass flux is sum of the molecular mass transport plus convective mass transport. So molecular mass transport, it use another expression kat sini. Ini, and then here. Okay. Okay. So that NA kita boleh substitute. So finally kita akan dapat seperti inilah. Combined mass flux of A is equal to rho A VA. Okay. So kalau kita guna another species atau another compound, so component A, for example, alpha here. For example, you ada sistem ABC. So rho A VA plus rho V beginilah. Okay. So finally this term you boleh is equal to V, total V, average. It's average velocity of the mixture, right? So times ni. So you akan dapati combined mass flux is equal to rho times with the V. Okay. Okay. Okay, jap Okay, so this is notation. Okay, this one I dah discuss tadi. This is for mass, this is for the molar. And then this one pun I dah discuss. Okay. And then apa lagi tu ni? Okay, so tadi tak settle lagi. So from here, sini, kita nak lihat balik. Okay, so kita tahu tadi NA kita combined mass flux is equal to, kalau tadi kita buat secara summary dia, so kalau kita tulis one by one, so NA JA plus rho AV kan, this is by molecular, this is by convective. Okay, so kita boleh rearrange kalau kita nak masukkan in term of JA ni menggunakan fixed law. So kita akan masuk is equal to this one and PAV is equal to okay. Row A, this is row A. So V here, V so V tu you can get from the first yang tadi kita dapat tu. Hang pula saya punya ni. Saya tak boleh nak tulis. Janganlah. Hai. Sekejap. Dia kena. Okay. Baik. Live class. Sekejap. Sekejap Hang pula. Okay, so combine tu tadi tu kita nak tulis dalam bentuk molecular transport and also kita nak tulis dalam bentuk convective. Sekejap. Okay, alhamdulillah. Okay, so tadi kita cakap dalam bentuk molekular, so kita involvekan the fixed law and then plus row AV. So row A maintain, so this V kita dapat daripada mana? Daripada yang tadi ni. Tadi kita dah bantu buat summary dia kan, daripada atas bila kita gunakan another expression tu, so kita akan dapat this one kan. So here kalau kita rearrange dia, so this V is equal to summation of N out divided with the V, okay, row. Okay, so kita nak substitute into the equation. Okay, this one, so kita masukkan ke sini. So sum and alpha divided with the density. class, can you hear me? Okay, saya terkeluar kat mana tadi? Aduh, this one dah ke? Ya. Oh, ya ke? Saya cakap seorang-seorang tadi. Supaya saya perasan. Kejap sabar kelas Nampak ke? Boleh nampak ke? Tak nampak lagi Sekejap Okay, nampak ke? Boleh nampak? Can you see the slide? Okay, this one kita dah belajar, dah sempat cover tak? Oh, yes. Okay. Okay, ini Okay, ni dah kan? Ni dapat This one dapat slide ni? Okay. Sekejap. Okay, so here. So kalau you can see the table 17.8-1 in your textbook, the notation for the mass and molar flux lah. Okay, so what is the important here? Okay, this is the important one here yang I dah circle ni. So this one you need to know the mass flux of species alpha here with respect to the mass average velocity. So this one number E and then number F here. The mass flux of species alpha with respect to the molar average velocity V star. Okay, apa beza yang E and F here? Dia hanya beza dari segi yang kat belakang ni kelas. Yang kali ni respect to the mass average velocity here. And this one respect to the molar average velocity V star here. Okay. And then you also need to know about the molar flux of species alpha. This one, molar flux. So, bila molar flux, kalau tadi dia ni adalah mass flux kan? So you guna density. So kalau guna molar flux, dia guna capital J. Tadi small letter J. So kalau capital J, instead refer to molar flux. So daripada density here, dia guna apa? C. Okay, so respect to the mass average velocity. This one respect to the molar average velocity, V star. Okay. And then also sum of mass flux is equal to 0. Tadi I dah buktikan. And then sum of molar flux is also 0. Okay. And then kita ada combined mass flux in term of combined mass. Okay, combined mass flux. So that kita ada yang ni. And then also kita ada combined molar flux. So capital M. Okay. So yang I make circle ni, that is the most important. Okay. Okay. Okay, this is only the summary. And then, okay. So for 4.3, the important one, first you must tahu about the convective mass transfer. So convective mass transfer is equal to rho A V, right? This is convective mass transport. And then beside that, you mesti juga tahu how to write the combined mass flux and combined molar flux. Okay. Okay. So kita sini kalau small letter this is mass combined mass flux, kalau capital N is the combined molar flux. Okay. Okay, for example kita kat sini. So kita ada NaX. So how to write? Kita tengok sini. This is the basic. So NaZ. So kita ada negative rho dAB, okay, divergent omega A. So kita dWA. Okay, what is the direction? It's a Z direction. Dx. This one how macam mana kita nak baca ni? Maksudnya component A diffuse in the Z direction, in the positive Z direction. So this is Z. Okay, and then plus omega A. So Na which direction? Z plus NB which direction? Z. Okay. Second one, component A diffuse in the positive Y direction. So negative rho dAB dW omega A over dy plus omega A and A direction kita Y plus NB direction Y. Okay, NaX component A diffuse in the positive X direction. So negative rho dAB d omega A per dx plus WA NaX plus NBX. Okay. And then formula. Okay, so molar the difference kat mana? Dekat sini. Itu saja. Okay, so that is here negative C dAB. So kita dx A component A direction Z. XA Z plus NA NB Z. So this one negative C dAB dXA directions Y XA NA Y plus NB Y. So this is X negative C dAB dX A direction X plus XA NA apa lagi X plus NB X. Okay. So ni kalau komponen A. Kalau kita ada komponen B, similar lah. For example kita ada NBZ. So kita ubah kat mana? Dekat sini je lah. So negatif for example negatif rho dAB dWB per D Z plus WB in bracket and BZ plus NAZ. Okay. Okay. Kenapa I stresskan kat sini? This is very important. Sebab nanti in the question dia akan bagi apa-apalah, maksudnya fundamental kita this one. The fundamental, the general punya. So dia bagilah kalau you punya axis in XY, katakan you dapat seorang dapat XY, so maybe yang lain dapat YX, lain mungkin dapat YZ, apa-apa, so that you boleh buat. Kisahlah any direction, tapi you boleh come up with the combined mass flux or combined molar flux equation. This is very important lah. Tak naklah nanti macam MTA, you punya soalan direction you XY, tapi you tulis nanti YZ. Janganlah macam tu. Okay. So this is fundamental. Okay, that's all. I rasa untuk 4.3. So 4.3, the important one, you tahu convective, mass transport, and also the combined mass flux and combined molar flux. Okay. So any question? Okay. So kalau tak ada soalan, so this week we don't have the tutorial. You can refer the model ada tutorial, tapi you can try by yourself. It's a very simple tutorial lah. And if you have any question, you can ask me. Okay, what's up? And then, okay, so that in terms of fundamental, I dah cover lah molecular and convective, and also how to estimate. So next week, insyaAllah kita akan belajar to develop the mass concentration by using shell mass balance. Okay. Okay. So if you don't have question, then I nak touch a little bit about the assignment. Okay, sebab ramai juga dah start tanya assignment. And I think, so I stop the recording first, okay? Okay. 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 So kalau tengok attendance hari ni paling tidak memberangsangkan ni. Half of the class je saya datang. Mana lain-lain. Okay, let's take a look the assignment. I rasa tak pernah discuss kan? Bukan tak pernah discuss, tak pernah rasa discuss. Cuma I bagi je lah assignment macam tu. And then maybe student confused kot, insyaAllah. Tengok ni. So I discuss sikit lah. Okay, first of all, this is the question. 90% banyak. Sekejap Soalan ni actually they involve the complex engineering problem. Okay, means that it's a very open-ended and you need to think how to solve it. Tapi sebenarnya senang je, cuma maybe tak nampak. Okay, kejap. Hang pula. Okay, so kata kat sini, the introduction ni 1.0. So this assignment utilize the approach of problem-based learning related to momentum transport. So this assignment is motivated by understanding the fundamental of momentum transport in solving and analyzing the problem given. Therefore, dia dah clear cut kat sini, dia bagi tahu you assignment ni berkaitan dengan momentum. Okay, means that you boleh fokus lah momentum punya chapter. And then kita tengok soalan. Okay, this is the question. So an example of shell and tube exchanger consists of a bundle of tubes contained in a cylindrical shell is shown in figure 1. So the tubes may be permanently positioned inside the shell, fixed tube shell exchanger, or may be removable for ease of cleaning and replacement. For example, floating head or U-tube exchanger. As a chemical engineer, you are required to design the tube of heat exchanger. The tube for your company. The type of the tube is designed as cylindrical tubes. Okay, so kalau heat exchanger, saya rasa dah belajar dalam thermodynamic ataupun heat transfer. So yang kat sini mana yang shell and the outer ni adalah shell. So inside the shell kita ada tubes. So the dark color ni adalah tube lah. This is tube. Tubes ni kelas sebenarnya dia banyak, dia bukan sikit. Maksudnya, kalau katakan yang satu saya ambil yang ni, dia mungkin consist of 100 tube macam tu, and then dibundlekan tau, baru dia bentuk yang ni. Maksudnya dia bukan satu, dia banyak. Setiap satu ni dia banyak lah. Itu cara dia. And then either dia permanently position kat sini ataupun kita boleh removal. Biasanya dia boleh removal. Sebab apa kita nak removal tubes ni, kita maybe you punya efficiency dah low. Dekat tubes tu maybe dia ada dah clogging ke atau dah start ada build up of the phlegm sebab kita guna lubricant ke as kita punya apa bukan solvent, kita panggil apa untuk bahan penyejuk tu kita panggil apa lupa, kita ada term dia tu lah. Okay, so maybe dia dah build up phlegm tu jadi dah tak efficient, so kita boleh replace kan, maksudnya kita boleh tanggal ni kita masuk another. Gitulah, jaranglah shell ni lah kita buang kecuali dia dah leaking ke ataupun dah leaking lah, biasa leaking lah. Okay, so yang kita nak design apa? Yang tubes ni lah. Just one tube. So tube kita ni kita nak design. So berapa dia punya? Dia nak soalan dia apa? Berapa diameter Okay. Pertama dia kata suggest a suitable inner diameter of the tube. Diameter of the tube by using relevant momentum equations. So the maximum friction factor of the tube is 0.01. So state all the assumption in design tube. Okay, sekarang ni you nak cari diameter. So dia bagi you friction factor. So this is friction factor. So this friction factor dia ada relate dengan apa? Reynolds number kan? So Reynolds number Yalah, this is the Reynolds number siap dia bagi lagi. Class, are you with me? Ada lagi ya? Ada. So Reynolds number, this one the Reynolds number. So you substitute lah dalam Reynolds number. So kita nak cari apa sekarang?
Diameter.
Diameter. So kat mana? Ni lah diameter ni kita nak cari. Diameter ni. So you rearrange lah equation ni. Finally you dapat D is equal to something. Right? Tapi taklah semudah ni kelas. Okay. Ni I bagi contoh lah. Okay, macam ni. And then density, viscosity bagi tak? Soalan dia bagi tak? It's not given, right? So tak bagi, then you leave your punya equation dalam density and viscosity. Okay, what about this one? Ni apa ni kelas? Apa tu?
Average velocity.
Very good. Average velocity. So how to get the average velocity? How to get? Azmi. Pandai. Daripada velocity profile lah. Maksudnya kita bentuk apa? Kita buatlah momentum shell balance tu ataupun nak guna appendix ke terpulang lah. Last sekali kalau kita derive apa target kita, main objective kita. Kita nak cari velocity profile kan? Dapatlah satu velocity profile. So from this velocity profile, kan saya cakap daripada main ni velocity profile, we can find or determine another property which is V maximum, V average and also the F kan, force. Betul tak? You buka balik nota dalam momentum. So you ambil lah daripada V ni masuk lah dalam ni, then you dapat lah diameter is equal to something. So kalau value tu tak ada, then you leave it dalam unit tu lah, dalam apa tu, variable benda yang tiada nilai tu. Macam tu lah. Okay, macam saya dah menjawab soalan sebenarnya. Sebenarnya saya nak ajar you how to think daripada macam ni kita nak analisis soalan ni. Okay. And then tengok B. So determine the mass flow rate of the fluid in the tube. The fluid used is water. Okay, sekarang mass flow rate. How to get this mass flow rate? Daripada kita kat sini rubrik ni dah sangat-sangat membantu. Rubrik ni dah bagi tahu. Okay, question B. Applications of the derived equation to determine the other property. So maksudnya daripada yang kita dah derive tadi tu, kita bolehlah cari kita punya mass. Mana tadi? Get a mass flow rate of the fluid. Cuma kat sini dia bagi water, dia guna water. So boleh kalau guna water, maybe in terms of density, viscosity tu, you boleh carilah. Sebab water is something very common. Sebab kita ada table property of the water, sebarang temperature, sebarang pressure ada. So macam mana nak tahu pressure dan temperature dia? Soalan langsung tak bagi tahu. So maybe you boleh assume, okay, you nak design you punya ni, kata you nak masuk you punya inlet water you dalam temperature berapa, dalam pressure berapa. So you boleh guna table property tadi untuk dapatkan density and viscosity and so on lah yang berkaitan. Okay. And then calculate the force. Sama lah. Force ni mesti F lah on the inner water surface of the tube. Then selesai. Okay. Boleh nampak? Nah ni satu hari siap ni. Walaupun kita bagilah banyak minggu. Okay, cuma okay, this one, okay. Okay, this assignment is by group, right? So kita ada 3 student or less. So make sure all student involved to complete this assessment. I tak nak yang seorang yang terror ni dia buat daripada A sampai C. Yang nombor 2 dan 3 tu dia letak nama dia je kat depan. Jangan macam tu. Okay? So yang leader tu you kena pandailah to delegate you punya work. Okay? For example yang number A, semua orang buat sama-sama number A ni and then everybody agree with the derived equation tu, then yang nombor 2 buat B, yang nombor 3 buat nombor C. Okay? Okay. Lagi apa Okay, dan dia akan submit pada 29. Ni ramai tanya. Okay, by 26 January means that next week. Okay, kalau dalam kalender akademik, kita memang adalah week 14. In fact, sampai sekarang pun kalender akademik mengatakan 26 ni adalah week 14. Dan kita punya syllabus saja kita akan try to cover pada study week. Okay, kenapa saya stick pada this 26? Okay, macam ni kelas sebab week 14, bukan, okay, week 14 next week. Okay, so this week, week 13, kita ada quiz. So week 14, I nak you submit assignment. And then bila study week ni, sebab I nak cover lagi syllabus, last kali syllabus. Dan kita tak ada study week lagi tau, terus masuk FA kat sini. And you punya CHE522 ni, dia akan minggu pertama dalam FA. Minggu pertama lah. Jadi saya tak nak you kelang kabut. Kalau saya kata okay, tak submit pada week 14 ni, saya ubah kepada study week punya submission. Kalau you nak submit pada waktu ni lah you nak submit you punya assignment, waktu ni lah saya nak bagi lecture, and next week you nak periksa FA cover semua. Saya tak nak macam tu, nanti kamu kelang kabut. At least saya pun try to nak settlekan syllabus ni dalam before the study week ni. Mungkin weekend saya buat just to make sure you have enough time to prepare before you masuk FA. Sebab saya nak you score sebenarnya untuk subjek ni. Okay? Sebab kalau saya tengok draft sekarang, you punya FA adalah pada hari Rabu, 9 hari bulan. Draft belum lagi yang finalize. Tapi memang dia akan minggu pertama lah sebab kita punya 522 ni ada 13 kru. So dia akan awal. So that's why saya stick pada minggu ni Okay. Sebarang soalan? Setengah jam ke Kita ada 3 soalan. Lemak saya lupa. Kejap Okay, ni saya nak stop presenting. Saya tak ingat lah you punya CHE522 ni, saya rasa 2 jam. 3 soalan 2 jam. Betul lah, 3 soalan 2 jam. 2 jam, 2 hours. 3 soalan 2 jam. So kita akan guna models lah. Okay, so make sure you memang dah expert lah. Saya dah ni dah okay dah. Macam hari tu pun cepat ni semua orang kan. Dan soalan tu memang randomly lah. Sama. Cuma dia beza sikit dengan MTA. Kalau MTA maybe you vary in term of the direction je kan. X, Y, startup. Untuk FA soalan dia totally different lah. Mungkin ada yang similar, different in term of direction. But ada yang banyak juga yang tak sama langsung. Dari segi set and set tu berbeza langsung lah. So tak sempat. Saya rasa, bukan rasa, saya memang jamin tak sempat tengok antara satu sama lain lah. Okay. In fact sepatutnya pun tak sepatutnya you discuss kan. Okay, sebarang soalan untuk quiz. Quiz kita akan buat pada hari Jumaat ni. InsyaAllah, tadi saya tengok dia bagi tahu. Bagi tahu tadi hari Jumaat dia akan buka for 24 hours. Awak nampak ke saya dah tak share screen kan? Okay. So dibuka 24 hours, Jumaat tu maksudnya daripada 1 minit hari Jumaat tu sampai malam. Tapi the duration is 1 hour. 1 jam saja kamu dibenarkan jawab. And it is a multi-choice question. So soalan dia randomly memang bezalah antara satu dengan lain, dan jangan bagi kawan kamu tirulah. Kalau tak, kamu jawab dulu, markah kamu dah rendah, kawan kamu dah tahu soalan, dia markah dia tinggi. Rugilah kat kamu. In fact, bukan rugilah, dari situ, dari segi dia punya integriti pun dah tak ada kat situ. Okay, jangan tiru. Itu satu, and then dia ada melibatkan derive equation. Soalan, berapa banyak soalan? Ada tulis ke dalam modul? Saya rasa sepatutnya dia dah tulis, saya tak sempat tengok lagi modul. Tengah hari tadi tak tengok. Saya 20 soalan ke 20 soalan ke berapa entah. Nanti saya update. Sekejap, dah boleh buka. Dah bersedia ke untuk ni? Quiz pun try score Okey. Awak punya MTA, saya dah tandalah sikit, baru 4 orang. 4 orang ke nak berapa lah macam 4 orang. Ada yang score is very good lah. You boleh tengok 4 orang tu, nanti saya akan share juga yang you punya yang saya dah marking. So the balance tu insya-Allah saya akan setkan esok sebab lagi 16 orang. So saya setkan esok so that before you masuk quiz tu, you dah tahu you punya MTA. So jangan main-main lah. Takut MTA you rendah, quiz you rendah, habislah. So that's why saya kata you kena score you punya quiz ni. Untuk yang markah rendah, pastikan you score you punya quiz. Sebab quiz 20%, banyak tu. Mana saya punya WhatsApp ni, kejap saya tengok. Sekejap. You tak nampak kan kat sini? Risau saya. Ada apa benda risau. Kau tahulah saya punya ni kan. Tak nampak kan skrin saya? Kasha tak, jangan tipu saya geng Kasha Yang satu hal saya masukkan tata tertib saya. Tidak saya tengok soalan tadi ada cakap tadi. Tak sempat tengok lagi. Berapa soalan. Saya punya dah lambat ya Allah. Mana ni? This assessment contain 14 question. 14 saja. 20 marks. Sikit. 1 jam. So 14 sahaja soalan mengandungi 20 markah. Maksudnya mungkin macam ni. Mungkin soalan ke 10, 11 tu dia markah dia banyak lah. Faham tak? Maksudnya you kena derive. So markah dia banyak. So careful lah kat situ. Okay. Only one attempt is allowed and 1 hour. 1 jam sekali saja boleh sit 14 question. So make sure bila you nak jawab soalan tu you dah memang well prepared, you punya internet semua okay, you punya kat situ tak hujan tak apa semua, internet okay, then you try to sit lah. Okay. Hari Jumaat tu ingatlah sikit sebab budak lelaki you ada nak sembahyang Jumaat semua kan. So pastikan you betul-betul dah bersedialah. Dan jangan pula semua nak buat malam. Kalau semua buat waktu malam nanti memang jam satu hal juga. Okay. So pilih waktu yang sesuai. Okay, sebarang soalan lagi before kita dismiss? Kita cover chapter 1, chapter 2 and chapter 3. Maksudnya momentum energy masuk. Mass tak masuk. Mass confirm masuk final. Okay? Boleh. Introduction tu yang macam chapter awal tu lah. Maksudnya basic fundamental tu. Ada lagi soalan? Nurul Atirah boleh? Nurul Ashikin? Nur Aswani?
Boleh.
Najwa Kristina? Nurul Nadira?
Boleh.
Siti Safira? Tak ramainya datang hari ni. Muhammad Alif, Muhammad Nazmi akan share. Lain di mana? Nanti kan saya masuk fundamental dia tahu macam mana equation ni datang. Okay lah, never mind. Okay, thank you so much class. Assalamualaikum. InsyaAllah kita jumpa next week, okay?
Thank you, Doktor.
Salam.
Thank you, Doktor.
You're welcome.